Let's consider the first case. Let's call it case 1, which is for every triangle ABC when angle C is an acute angle. So let's have the image of triangle ABC. A, B, C, of which angle C is acute. Now, opposite angle A, let's call it the small a. Now, between line BC, the midpoint, let's call it D, and let's call here A1 and A2. Opposite angle C, let's call it the small c. Opposite angle B, let's also call it the small b. Now, line AD is our altitude. Let's call it H. To find angle C, let's use the trig ratio using sine. To find angle C, let's use sine C. So we'll have sine C to be equal to opposite C over hypotenuse C. And what's our opposite C? Opposite C from triangle ACD is H. So sine C will now be opposite C from triangle ACD is H over hypotenuse, which is B. Now, making H subject formula by cross multiplying, we have H to be equal to B sine C. Let's call this equation 1. However, since we are trying to prove the area of triangle to be equal to 1 over 2 AB sine C, now recall that the area of triangle is equal 1 over 2 base times height, which is the altitude. This is the formula for finding area of triangle, which is half base times height. Therefore, the area of the triangle, which is 1 over 2, 1 over 2. What's our base? Our base is A times height. And what's our height? Our height is H, which is the altitude. But from equation 1, H is equal to B sine C. So let's replace H here with B sine C. We now have area of triangle to be 1 over 2 A times B sine C, which means the area of triangle is now 1 over 2 AB sine C. This is how to prove the area of triangle when angle C is acute. And let's also check case 2. For case number 2, for every triangle ABC, this time around, it will be when angle B is obtuse. And of course, for angle B to be obtuse, it means angle B is greater than 90 degrees. So let's construct a triangle that has angle B to be obtuse. Here we have A, B, and C. And angle B here is obtuse. Therefore, let's form a right angle triangle for triangle ABC. Also, opposite B is small b, opposite C is small c, and of course, from let's also call this D. From DC, which is opposite A, let's call it A, and DB, let's have it as A1, and BC, let's have it as A2. Length AD is our altitude, let's call it H. From triangle ACD, which is ACD. Now let's find sine angle C. Sine C, which is opposite C over hypotenuse C. What's our opposite C, which is H? Therefore, sine C is equal to H over hypotenuse C, which is B. Let's also make H subject formula. That makes H to be equal to B sine C. Now, recall that area of triangle is half base times height. Therefore, we have the area of this triangle. Area of this triangle ACD should now be equal to half base. What's the base? DC, which is A, times height. What is the height? Which is the altitude, is H. Now, we have our value for H to be equal to B sine C. So, let's substitute H with B sine C. That makes our area of triangle to be 1 over 2 A times B sine C. Hence, our area of triangle will now be 1 over 2 AB sine C. This is how to prove the area of triangle when our angle B is obtuse For case number 3 is for every triangle ABC when angle C is 90 degree or right angle. So if we have angle C to be 90 degree or right angle, let's prove that the area of triangle is half AB sine C. So let's consider triangle ABC where angle C is 90 degree angle C is 90 degrees, so this should be our position for angle C. B, and opposite B, of course, we call it B. Opposite C, let's call it C. Now let's also attach distance AD let's call this D, so that to get our side A would be from distance DB, which is A, and of course here should be our A1 and A2. So from this triangle where angle C is 90 degree, let's prove that the area is equal to half AB sine C. Now recall that area of triangle is equal to half base times height, which is the altitude. Hence, our area will now be half base. What's our base? Our base is A, which is dB. We have it as A times our height. What's our height? Which is AC and is B. Since angle C here is 90 degree, is equal to 90 degree, that makes sine C to be equal to 1. So comparing area of triangle to be half AB and angle C, which is sine C, as 1, we'll have the area to now be 1/2 AB times 1, where our 1 here is our sine C, because sine C is sine 90 degree and sine 90 degree is 1. Now we can also say that the area is equal to 1/2 AB sine C, since sine C is 90 degree. I hope this video is helpful. Please, if you're just joining us for the first time, don't forget to hit the subscribe button to keep enjoying exciting mathematical posts. And if you subscribe, kindly stay tuned. Thank you.